Welcome back. The objective of this video is to use differences to determine the degree of a polynomial function, and we'll sketch a graph with repeated zeros. The degree of a polynomial function can be found by examining the successive differences of the output values over equal interval input values. The degree of the polynomial function is equal to the least value n for which successive nth differences are constant. So in example 11 here, we'll use the table below to determine the degree of the polynomial. So we'll continue finding differences until we get to the point where the differences are all equal. So looking at our original function here, we'll look at the differences in the y's. How far is it between negative 30 and negative 14? Our first difference there is 16. And negative 14 to negative 12 is 2. And that first difference is 0. And that's a positive 10. And 32 and 66. So now we'll keep going. We'll look at the difference between 16 and 2. That'd be negative 14, and 2 to 0 is negative 2, and 0 to 10 is positive 10, and 22, and 32 to 66 is 34. So once again, these aren't the same. Those differences aren't the same. So this is not a second degree polynomial. So let's try the third differences. How far is it from negative 14 to negative 2? Well, that's a positive 12. From negative 2 to 10, another positive 12. 10 to 22 is 12. 22 to 34 is 12. Our third differences are all the same. This is a third degree polynomial. In example 12, we want to sketch a graph with repeated zeros. So we're going to write a polynomial function of minimum degree whose zeros include the following with a greater than 0. That means our leading coefficient is positive. So we've got a 0 of negative 3 with a multiplicity of 2. We've got a 0 of negative 1 and a 0 of 4 that has a multiplicity of 1. So let's take a look at what we got here. X equals negative 3. That's going to come from the factor of x plus 3. So we have a 0 of negative 3. So that's going to come from a factor of x plus 3. And that has a multiplicity of 2. We have x equals negative 1. So that's going to come from the factor x plus 1. And we have x equals 4 is going to come from the factor x minus 4. So we FOIL all this together. I will do that for you. X plus 3 quantity squared is x squared plus 6x plus 9. And x plus 1 times x minus 4 is x squared minus 3x minus 4. So we still have to FOIL this together and get our polynomial function. So multiplying or FOILing these two trinomials, I'm going to take the x squared in blue and multiply it by all three in the right-hand factor. Then I'm going to take the 6x in red and multiply it by all three. And I'm going to take the 9 and multiply it by all three. I've color-coded this for you. So we get x to the 4th minus 3x cubed minus 4x squared for the blues, the reds, and the greens. And then we just add all those like terms up because we've lined up our like terms. So this is going to be real easy. So we get x to the 4th plus 3x cubed minus 13x squared minus 51x minus 36 is our function. The next thing we're asked to do is to complete the table to determine the behavior of the function. So we'll have a bunch of ordered pairs and we can take a look at that function. So we can put our x's into our function and find our y's. Now normally we would put our x's into this black long polynomial function here. But you actually might find it easier to put some of these values into the factored form. as I've done below. So if I put negative 4 in to the factor form, I have negative 4 plus 3 quantity squared, which is negative 1 squared, which is 1. And then negative 4 plus 1 is negative 3, and negative 4 minus 4 is negative 8. So this just shakes out to negative 3 times negative 8, which is a positive 24. If I put negative 3 in for x, well, this factor is going to become 0, so everything becomes 0. When I put negative 2 in for x, I'll get 6. I put negative 1 in for x, well, the middle factor, x plus 1, is going to drop to 0, so everything becomes 0. When I put 0 in, I get negative 36. When I get 1, I get negative 96. When I put 4 in, my factored form, that becomes, this one factor becomes 0. So the whole thing is going to collapse to 0. And when we put 5 in, that's a lot of work, we're going to get 384. So now we have a bunch of ordered pairs that we can plot down here for our polynomial function. I would begin by plotting at least the zeros. So we've got some x-intercepts here at negative 3, negative 1, and 4. So negative 3, negative 1, and 4, we've got some x-intercepts. Now we're not going to be able to do this to scale, but we saw that negative 4 gave us an output of 24. So that might be there, negative 4, 24. And negative 2 gave us an output of 6. So maybe a point right there. We had a double root, if I remember correctly. Yep. Negative 3 had a multiplicity of 2. So at negative 3, we're going to bounce at negative 3. So our graph is going to bounce here. And at negative 1, that's going to be a pass-through. We've got a y-intercept of negative 36. So that's going to be down here somewhere. And at 4, we had a 0. 1, we had negative 96. So that's going to be way down here. And at 5, we were just way off the charts. So the other thing we should notice is this is a 4th degree polynomial. So it's an even degreed polynomial. Our end behavior is going to be in the same direction. And because x to the 4th, the coefficient is positive, we have a positive x to 4th. So our end behavior is going to be in the same direction, and it's going to go positively. So we know, since we don't have any more x-intercepts, our graph is going to head through that point. And from negative 4, 24, it's going to head that way. And now we really are just connecting the dots. We've got to pass through all these points. So I'm going to have to pass through 1, negative 96. I'm going to have to pass through my y-intercept. My 0 at negative 1 is a single root. So I'm going to pass through. I've got this other point here that I didn't label. And negative 3 has a multiplicity of 2, so that's going to bounce. We're not going to pass through. We're going to bounce off that negative 3. And there is the graph of our function. Question D says, on what interval is f of x greater than 0? So where are the y's greater than 0? Well, they're greater than, the x's are greater than 0 from negative infinity to negative 3. And then from negative 3 to negative 1. And then from 4 to infinity. So we'll write that as negative infinity to negative 3. And then again from negative 3 to negative 1. It's not inclusive because it's 0 at negative 3, and then we've got greater than 0, so it's got to be positive. And then also from 4 to infinity. So Those are the positive ones. On what intervals is f of x less than 0 or negative? That's going to be non-inclusive of -1 to 4, and also non-inclusive of 4. And that finishes up our graph of a polynomial with repeated zeros and our introduction to using differences to determine a degree. And you'll get some more practice with that when I see you in class.